Developing XNAT plugins. This will be obviously of interest to people who are programmers and are writing custom code and really want to extend the system, but I think it'll be of interest even to people who are not. If you have any existing customizations of XNAT data types and UI elements that you want to be able to migrate into 1.7, the way I'll talk a little bit about how you can do that without writing any Java code. And if you maybe have people who will be doing development work, you can kind of see what that work will look like and how to work. So there's kind of a full range of levels of being able to use this stuff. So plugins are brand new in 1.7. We're going to look at the plugin architecture and practical aspects of developing your own plugins to extend XNAT. And if you have any particular questions, I got to kind of try to get through things by 11:45. So I can try to address any questions that you have, but if it's going to be something that's going to get kind of deeper into stuff, if you can, you can go ahead and ask, and I might say I'm going to have to get too deep for that, and we can hold on to it and go back to it a little bit later. The afternoon practical is going to be all about this as well, and we'll really get into some more of the technical aspects and really into the weeds of how this stuff works at that point. Okay, so introduction. What is an XNAT plugin? An XNAT plugin is just it's a plugin for anything else. It's a thing you can pop into an XNAT and extend the functionality. You can add new data types. You can add UI elements. You can add code that'll do things inside. We'll go into some of the specifics that the framework provides you easy ways to accomplish. And then technically speaking, you can do almost anything because we really provide access to, and we've mentioned Spring earlier, to the Spring framework, and just kind of anything that you can do with that, you could do in a plugin. It might not be a wise idea to do it in a plugin, but you could. So how do they differ from modules? Prior to 1.7, we had the builder, and the builder had this kind of multi-stage process of how it took things from one folder, sort of staged them into a projects folder. You could slip code into that projects folder, and then that would get built into the deployments folder, and that's what ended up becoming your XNAT application. So really anything that you had to customize XNAT was pushed into XNAT. It became part of your XNAT deployment. And a module was just a way of zipping up the code for your extension, and literally all we did was extract it and pop it into that projects folder. But a plugin in 1.7 really is a plugin. It's a jar file. It gets picked up on the class path by the XNAT application, and you have compiled code in it. You can have data types, you can have scripts, you can have all kinds of stuff in there, and then you can take it away. Because it's a plugin, it's not integrated into the application, it sits outside. What functions do they offer? Like I said, kind of everything. Data types, UI extensions. There are a number of different coding frameworks that we provide that make it pretty easy to be able to save data into the database without having to write database code, that lets you create scheduled tasks, that lets you create and consume events. And Mike Hodge will talk about that a little bit later, about how to ways that you can use that and ways that you can implement it on your own. With all of this stuff, we're starting to make it so that XNAT can be this really responsive and extensible framework that you can put things in and be able to provide custom functionality to deal with sort of standard things that happen inside of XNAT and things that exist inside of XNAT. Like I said, because of the fact that we've got a full coding framework, you can literally do anything. Some things might not be a good idea to do, but you can do them. So it's a matter of discretion on your part. So you want to go get a plugin. What are you going to get? The simplest answer is a standard Java jar file. You don't really have to know too much about what that is, but it's a zip file, and it's what the Java language uses to create libraries. So you do a whole bunch of things, whatever they are, text files and graphics files and XML files and compiled Java classes, non-compiled JVM-based scripting language files, all kinds of things, and you zip them up and you put them in this file. That's a jar file. It integrates into XNAT through XNAT 1.7's customization of the Tomcat class loader. Basically, we have what's called a context file in the servlet context, and there's too many uses of the word context, but that's not my fault. I didn't come up with that. But the context is literally sort of the environment in which your application runs, and we modify that to say that there's another folder over here that we want you to treat as one of your sources of where you're going to find your libraries and stuff. And there's always a standard place that a web application goes, that it goes to find all of its jar files, all of its code resources, and everything that it needs to run, and we just stick another one on. And in the practical in day one, we set up a folder called XNAT Home, and one of the places we want to look in there is a plugins folder. And that plugins folder is where you're going to put your jars. At this point, there's no flexibility on that. That's just where it's got to be. Kind of thought about maybe making it so you could say somewhere else, but I don't really want to. So compiled Java classes load normally, but web resources like JavaScript, CSS, images, anything that you want to, velocity templates, anything that you want to have in your web app, things that are going to be displayed on the screen or consumed by someone from outside to go to a particular address within your website, you can stick them all in there. And I talked a little bit about this on Monday, where there's a standard in the new servlet specification that says if you put stuff in this folder, it's in the web app. It's as good as being in physically located in the web app folder. So we take advantage of that to be able to put things into these jar files, and now they're loaded like they're in your web app. The great thing about that is that removes, you get the practical effect of sticking your stuff into the web app, like we used to in 1.6, but without the impractical and annoying side effect of mixing everything all together into like one folder. People kind of freak out a little bit when especially if you got like a lot of customization code. Like, oh, I got all these modules, so what am I going to, how are they different? I said, the modules are a way to package code so that you can get them integrated into the build. And once you've done that, they become an integral part of the deployed web application. But plugins are separate and distinct because they live in their own little container separate from the web application. So what can you do with them? So you add in data types, and that's the first thing that you want to be able to do, right? Is to be able to add in a new data type because you've got a thing that you want to collect. You want to be able to collect specific demographics data that XNAT doesn't support directly. You want to be able to collect subject history, family history. What other ones are enormous ones that we've done with these things? There are all kinds of different data types that are out there. The good news on those is that you don't have to do anything to those. The XSDs are exactly the same. The structure is pretty much exactly the same. You'll put them in a particular folder in your plugin, and they will go. Display content and simple UI definitions. For displays, if you've already got velocity templates that go with your data types, you're going to put them in a folder in it's a little bit of a different location in the plugin structure, but that's it. It'll all work exactly the same. So migrating from modules to plugins is not going to be hard. Ginny's extremely skeptical, but I'm and simple UI definitions. There are so you can continue to use your existing VMs. We've also got ways to control any parameters or values that you need to be able to set for your plugin or for any extensions that you've got that don't require you to write any velocity at all, that don't require you to write HTML, and that's in the spawner library. We'll look at that in a little more detail later on, but I think it's one of the coolest things that we've got going. Persistent preferences. God, that's slow. You also want to be able to save stuff so that you can just set kind of what's the default parameter for this value, and what's the what group of users or groups of users can access this particular feature that we're implementing. But you don't want to have to learn how to write SQL queries and or JDBC code, or learn how to do database transactions. You're just like, I just want to save it, man. We've got a really cool framework for doing that. You can write a Java class, and some people are like, I don't want to do that. But these are really easy. I'm not kidding. It's really simple stuff. So you put a thing on it and say that this is my preferences class, and here's a preference, here's a preference, here's a preference, and then you can just get and set it, and it gets saved out, and you don't have to write database code. You don't have to mess with any of this stuff. Configurations. There's also an easy way, once you get into a little more coding, if you are someone who's like, does want to get into doing some Java stuff and extending the functionality of your plugin, it's really easy to sort of like unite everything in one configuration and kind of wire it all together and wire it into XNAT and wire things from XNAT into your plugin. So you've got access to all of these resources that are already running in XNAT, and that's really easy to sort of pull them all together and take advantage of that. You can write your own REST functions. You can write your own self-documenting REST functions, and it's really pretty easy. You can create your own scheduled tasks. So if you need to be able to go out and check for data having arrived in a particular folder, if you wanted like a Dropbox function. So you can go out every minute and go look, is anything new, is anything new, is anything new, is anything new? That's really easy to do. Previously it required editing an XML file and doing all kinds of stuff, and now you don't have to. You write one class and you set your scheduling information in that. And events. For a lot of people, you won't ever want to look at events or deal with them other than through the UI. But from the UI standpoint, there will be events in XNAT that you can handle in customized ways by adding scripting, by adding by the time we're done with container services, you'll be able to do things like, and one of the things that we want to do for one of our workflows for our tip system is have a session come in, have them proactively push a session over to the XNAT that runs the tip system. When that arrives, we can run an automated QC process on it, automatically route it to the correct project, automatically run a QC process, automatically notify our radiologist that it's time to look at the QC that we just generated. The radiologist looks at it and says, yes, that's another event. We save that. We see that that passed, and now we can go through and automatically send the data back out to back over to the PACS that will go over to the surgical team. So everything happened other than one human intervention that was required to actually review the data, whereas now we have human involvement at like 4 or 5 steps of the process. So without actually even doing anything with events, we can make a whole lot of cool stuff happen. So plugin development 101, building. To build a plugin, we wrote a plugin for this build tool called Gradle, and we did it because Gradle is really easy to extend. It's based on Groovy, which is a scripting language that is itself derived from Java, but it's really pretty easy to learn. Even if you know Java, it's really easy to learn. You can pretty much take Java and stick it in there. If you don't know Java, it's pretty easy to learn because it's a very readable sort of, kind of natural language flowing type of scripting language. And it was really easy for us, or relatively easy, I should say, for us to integrate all the functions that we had in the XNAT builder in terms of parsing the XSDs and generating Java classes and velocity templates and display documents and all these things, and integrate that stuff directly into the plugin. And Tim did it in a few days, and I think a lot of that was kind of figuring out how to sort of take the parts of that process that we wanted to keep at that stage and get them into the correct, the output results of that into the correct location. From the standpoint of someone building a plugin, all you do is you just put in a line that says, apply plugin, and then you've got it, and it will do all the stuff. It'll go out and look for it's wired directly into the build process. It'll go out and look for data type schemas. It'll go out and look for, pretty much data type schemas. And it'll generate everything off of that, everything that you used to get from the old builder process. And that includes the beans jar. But the good news is, for Ben Wagner, the beans jar is much less important now. So I don't have to sign it for him on a daily basis. No, he sort of demanded it. Installing it is even easier. You have run your build, and one of the things it generates is a jar file with some stuff in it. And you take the jar file and you put it in your plugins folder. Restart Tomcat, and you're done. That's installing it. The XNAT plugin development requires the use of Gradle. The cool thing about Gradle is you can basically take one of our sample plugins, throw everything out, and they come with a couple scripts, GradleW and GradleW.bat. And if you have those things, and there's a Gradle folder that's got one small jar file in it. If you have those things, it will go out, you can run one of those scripts and it'll go out and it'll download Gradle. So you don't have to install Gradle on your system and go, oh yeah, and I got to maintain something else, that's a pain. No, just run this script and it will go out and it will download a jar from the Gradle site and install it in a local cache, and that's what it'll use to run the build. So I have Gradle installed on everything that I've got, but I almost never use it directly other than to regenerate these wrapper scripts. And so what's cool is if you want to get someone else's plugin and build it, you can just clone the repo when it comes down on a clean machine. There's nothing installed on it. Run .gradle/w or ./gradlew, and everything will get downloaded and it'll get built right in place. So it's super handy. And we created a plugin that handles a lot of the work previously done during the setup and update process. So when you basically add 3 lines. One to add our Maven repo to your script. One to say that I need that plugin file, and then you apply that plugin file, and that's it. So these 3 lines will get everything that you need to build your module, your plugin. Not a module. Okay, let's look at a sample plugin. Hopefully I can make this sort of readable. And I apologize in advance if I can't. So this is, and actually especially if you're going to work through the practical, I've pushed a couple updates up this morning actually to the Git repo, or GitHub repo. I'm not sure where it's at actually, for the XNAT plugin, or the workshop plugin. No, that's not it. And you could pull from that and refresh. I want to tell you where it's at. It is, on github.com/XNAT workshop, and then the XNAT workshop plugin. If you've already downloaded it, you can refresh it. If you haven't, you can clone it, and there's also a download link, and you can just download it as a zip, so you don't have to mess around with any of the cloning and whatnot. So, and that'll give you some, if you want to kind of follow along with the code, that might be a good thing to do. So, I should show you what the structure of this is like. At the top level, and I know this is kind of hard to see. Okay, so this is the contents of the plugin file. These are the build files, the .gradle files. Here are the scripts that I talked about, gradle.w and gradle.w.bat. And then this folder, the Gradle folder, holds the jar files. They're kind of like these bootstrap files that will get you going to go out and do the download and stuff. Basically, your build is defined in the build.gradle. A lot of that stuff's going to be pretty boilerplate. And we're going to be working on paring it down. It's kind of verbose right now because there's a lot of stuff that we filter out. We have a lot of old dependencies from in XNAT Web and in the XNAT Core, and so we filter them out for the plugin. We're going to try to move that off somewhere so the build file will become a little more succinct. And then under the source folder is where all of the stuff for your plugin lives. And the build folder is the output folder. When you build, it puts stuff into build, and you get kind of a lot of stuff that comes up in there. Classes that get built. Is that better? You see that? Oh, you know what? You know what? Okay, is that easier to read? Yeah, okay. The problem now is the text is not at the bottom of the screen, so it's harder for me now. Yeah, the build folder is where everything gets built into. When you first clone one of these projects, you won't have that, and when you run the Gradle script, that's what it'll generate. And then the source folder. Next, I'm going to go this way. That's not really good, is it? No. The source folder. Really, the only thing that you care about in this structure is main. The beans and the generated folders are both generated. Those are the things that are created on the fly by the XNAT plugin, and the main folder. Oh, I guess if I did this, has a few things in it. There's a Groovy folder, and I don't actually have any Groovy in here, but it generates it automatically because I have that plugin in there. So in Java, I have some classes in here. I'm just going to do this, hold on a sec. Okay, so that's the classes that I have in here. I'll go through these in a lot more detail in the practical later on. But this right here, this workshop XNAT plugin, is kind of the key piece of Java that pulls everything together. And even if you don't really want to do any Java development, having one of these plugin files can give you a lot of power, because it will let you, if you've ever added a data type to XNAT, and after you've run all your scripts and you've brought it back up, you have to go to the setup additional data type function, and you've got to put in you got to go through and you find your data type, and then you got to enter in the singular and the plural name, and then you got to go and set things and then go through that process. And now it's available. We have the functionality in the workshop, in the XNAT plugin structure, to do all that stuff kind of out of the box. And as XNAT goes through and discovers your data types, it'll find the configurations in the plugin class and use those to automate that whole process for you. So you'll come in and immediately your data type is configured with names. You can add a modality code. You can set it as and by default, it's automatically considered a secured element. You have to actively go in and say that you don't want it to be secured. And that secured status is what makes the data type available and not stuck kind of in the back closet. The other stuff that's in here is just some functions that are kind of cool, and we'll look at those in the practical. But here's a REST API. So I just create a REST API and it will be available. This is a preferences class, and I can store stuff in the database. But in here, in resources, this is the, oh, nuts. Okay. This will look pretty familiar to anyone who's done it. Whoa, what just happened there? That was strange. Okay. To anyone who's done a data type, there are a couple schemas. There's a workshop schema, and that's got a single data type in it, which basically I just took the GenFi biosample collection data type because it's really simple. I didn't want to get into anything complicated because I'm not trying to talk about how to build complex data types. I'm just trying to show you how to get your data types into a plugin. So it's like 5 Booleans. It's super easy. We've also got a rad read data type that I think we used for the last workshop, or we used for something. It's actually used. And that one's got a custom display document, and then I've got some pages for them. So the report for the rad read, an edit and a report page for the biosample that's been customized from the default generated one, and another one that is actually an extension of the actions box that shows up on the subject data page. And we'll talk a little bit about extension points within XNAT later on, but this is saying basically for subject data, if you're on a subject data object, there's an actions box there. And if you look in XNAT itself, this folder exists in the XNAT-templates folder, and it's got, I think, 4 files in it. So manage files, upload or something, I don't know what else in there. So this is actually how we move to extending our own UI directly in XNAT by putting files in there. And XNAT goes out and looks in these folders and says, what's in there? And it will just load those things up and stick them into that box. And so you can extend it just by adding your own files in there. And these points exist all over XNAT. They're not documented directly because they're self-documenting. And we'll have a look at how that works. So if you have a data type schema, this is how you migrate it. You put it into this structure. So right now I'm in source main resources, schemas, and then your schema folder, and then your schema. Same thing with display documents. As you can see with the rad read data type here, this is the standard location for a display document. It's in a folder called display right next to the XSD that it helps to modify. These get packaged up and put into the jar files that we generate. And when you start XNAT goes out and looks for everything that's in schemas/something/something.xsd. These meet that criteria. Workshop is something. Rad read is something. So you got something/something.xsd, and that's what that is. It'll go out and it'll find it. What we did in previous versions of XNAT is when you ran the builder, that was part of that process. To go through, look at these schemas, look at the database, and say, do I have this type? Do I have the tables for this type in the database? If no, I'm going to generate the SQL to create these things, the whole structure. I'm going to create it all now. If you do, say, okay, this is what it should look like now based on this schema. What does it look like over here? It's missing a column. I'm going to put some SQL in to update this to add that column. And as we mentioned earlier, if you've changed the type of a column, then things get a little squirrely. But it will actually generate the SQL for that in that case. That whole process now is pushed off. We don't do that. There's not a whole separate command line step to manage that. Instead, what happens is, as the application comes up, it does the same process. It goes out and looks for all the XSDs, looks to see what those need as far as the SQL schema, and runs that whole process, but it's on XNAT initialization. Which is really cool because now you can deliver this one package to someone. All they got to do is plop it in and restart, and they don't have to go through this, kind of rigmarole. Let's see. Yeah, so that's what a plugin looks like. This is the structure of a building, working, functional, useful if you use your imagination plugin. And we can talk more about any specifics around that stuff in the practical and look at some of the code and with that. So this is all in there. For data types, you have XSDs, display documents, default and custom UI elements. And what I mean by that is that we generate actually a bunch of velocity templates. And I kind of reference that a little bit. Yeah, so we look in source generated resources, meta-inf resources. And I've talked about this a little bit before, but this meta-inf resources thing is a Servlet 3.0 specification thing that makes your stuff look like it's living inside the web app. So you can see here in this base templates, we actually generated a default edit page for our biosample collection type and for the radiology read type, a default report page for each of them, a default search page. Those pages actually work. They are usually not very pretty, but you can use them as a basis oftentimes for your own custom stuff. Right. Display content. So VM templates with hierarchy. Oh, no, sorry. Just look over to the right to see what's coming in. I presume that it's there. So VM templates with hierarchy overrides. What this is there's the one thing that's really cool about Turbine, and Tim was talking about this earlier, it's kind of this between Turbine and Velocity, it's this older framework that there is a 2.0 that's been in beta since like 2010 or something like that. So I don't think the beta's going well. But one of the things that's really cool is this idea of kind of a hierarchy or a precedence in terms of how it resolves pages that it's looking for. So when you address a page, you say, I want this page. It's a screen/foo.vm. And it doesn't try to translate that into a direct path to a page. Instead, what it does is it says, I will take this path and I'll start it with, first, templates. Template/screen/foo.vm. Do I have that file? No. Templates module templates/screen/foo.vm. Do I have that? No. XNAT template, and so on until it finally finds something. And if it doesn't, then it will throw an error. But and what this lets you do is XNAT provides. We don't provide anything above XNAT-templates in the hierarchy, and that gives people who are writing plugins 2 folders above that in the order of precedence: module templates and then templates at the very top. To override things, to inject your own implementations of things into the UI. So for example, we have a lot of people who don't like the standard project page, who want a completely different view. So the standard project page for us is in XNAT-templates/screens, XNAT screen report, XNAT project data.vm. It's very verbose, but you take that same file and you put it in templates/ and then all the rest of it's the same. And you now have your own version of the project report page. And when you go to a project page, that's what you're going to see, not the default XNAT one. So that's actually a really cool functionality, and you can utilize that both to override existing or default page implementations and to extend to your own page implementations for custom data types or whatever else. JSP, Tim alluded to earlier, we actually kind of always could do JSP. It was just sort of a pain in the neck. It's less pain in the necky now. And so you can take advantage of a lot of the libraries that are out there for JSP. And even if you wanted to, there's a lot of other kind of more modern templating services that you can integrate. So there's Timeleaf, and there's another competing one. Timeleaf is the one that Spring kind of pushes on you. They're big fans of it. I don't think it's all that, but it's fine, I guess. HTML-less UI elements, and that's the spawner system. We're still a little squishy about exactly how you'll integrate spawner elements into your own UIs. We'll have that worked out fairly soon. But for right now, you can inject your own definitions into anywhere in the system and have them kind of appear. And so it's a really cool way to be able to extend things without having to write code or write HTML and worry about your table tags and CSS and stuff. Everything will be consistent when you write something in the spawner YAML format and it gets rendered out. It's going to look like everything around it. It's not going to look like you took HTML from 1996 and sort of just slapped it up there, and then it got it integrated into this thing with a blink tag. And no, it's all going to be consistent because we're actually rendering out the code off of your specification. Persistent preferences, again, this is a thing that I'm actually really excited about because it lets you take any settings or things that you want to be able to store for your plugin, and you write what's called a bean. And if you don't do Java, a bean is a piece of code that does nothing but carries data around. It's a little data container. You got a thing that says get my property, and that'll return the property out to you. And you say set my property, and that's it. It doesn't have any functionality around it that you have to worry about. For our beans, the functionality is all pushed away where you don't have to see it. And so when you say get my setting, set my setting, it's going to get persisted out into the preferences system, and you can actually scope that setting to almost any entity within the system, which is what makes it really cool, because you can have a setting overrides down to, for example, the user level, and then up to the next group level, then up to the role level, and then up to the site level. So for something like for the default view setting, what view do you want people to have? They log in, and now what page should they see first? We can actually change that based on the, like I said, all the way from the user up to the top of the site. There's no database transactions required, at least not explicitly, so you don't have to worry about dealing with the transaction managers and the session managers and when do I commit, and it's all going to happen for you. And you can easily override the standard preference handling and not even use our preference management system with anything else that you want. So we actually have some situations where we're taking configurations and we're storing them in another area of the system, and that's all mixed in with preferences. And from the standpoint of other bits of code that are calling into the preference beans, they don't see it. They don't know. They don't care. All that happens is when you do a get and a set, you get the appropriate values back out. Plugin configuration, I got to get moving here. So plugin configuration, everything's centralized into a single class per plugin, and we'll look at that in more detail in the practical, but basically you put an @XNAT plugin annotation on the class, and then you can hang some other things off of that, and everything will get pulled in. But it's not even necessary. So if you've got data types already defined with velocity templates and some Java code, and you're like, I don't want your new fangled systems and your fancy builds and the other stuff that you got, man, I just want this to go. You have to move them into a little bit different directories, and that's it. Use the build plugin and you'll be good to go. But it is very helpful because, as I said, with the way of defining the data models on the plugin level, you're going to avoid a whole bunch of configuration that you'd have to go in and do in XNAT manually once you've installed a data type. To write that level of Java is actually pretty turnkey. It's pretty easy to do. Yep. Okay. And the plugin will handle data types, REST controllers, services, etc., blah, 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 because really it is, like I keep saying, you can do anything you want to. It might not be a good idea to do it in XNAT because someone really doesn't need a service to reserve a table at a restaurant integrated into XNAT. But you could do that if you wanted to. It would be dumb. And I'm not saying you should do that, but you can do it because it can all be integrated in through this configuration file that will bring in whatever services you have available and let you configure them and run them. REST controllers. So the REST API is probably the primary way. I know a lot of people said that they've used it, and that's because it's probably the primary way people actually script XNAT or control XNAT externally. The way we're doing REST controllers now is much, 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 much easier. So if you want to write your own custom REST controller, it's easier. It's annotation driven, which lets you just kind of like specify things in a non-very codey sort of way. We use a well-documented mature framework in Spring MVC. The Swagger documentation is awesome, and it even lets you actually access the REST API live directly through the Swagger stuff. And you can even use standard Spring MVC for complex UI implementations if you want to. And MVC is model view controller, and it's basically a way of rendering pages and doing form submissions and handling data transactions back and forth between the browser and the back end. Scheduled task, it's easy to do. They're called trigger tasks. And you create them, and you can do like cron expressions, you can do periodic delays, you can do, there's all kinds of ways that you can configure them. It's a very well understood, well tested framework, and it's super easy just to create one and throw it in. Events, we use the highly scalable reactor framework, easy to create and consume them, and that's where Mike Hodge gets to talk. I've just got 2 more slides that aren't even any details. So things that we'd like to do, make task queuing easy. Right now, we don't give you really good access to be able to put things onto into queue processing, and that's going to be really important, especially as we're looking at where we're going to be going with the XNAT architecture moving forward, to start breaking things into small pieces. So if you've heard of microservices architecture, that's really what we're looking at doing. This is what you need to be able to do to work in a kind of a scalable and really elastic cloud configuration. Because what you want to be able to do is have small things that are running out on machines that are very focused on doing one task. And so if we need to do one particular type of process and we can stand up 100 of these machines that are only doing that, and the way that they actually get their work is not by someone proactively saying, you do this, you just keep adding things to the queue. And now we've got 100 little workers that go out and they each take their job off the queue. And then when they are done processing, they're done, and they fire off an event to the event bus that goes out to everyone in the cluster. And so you can react to it. Try to remove more scaffolding code from areas like within getters and setters and the preferences bean. The preferences beans are really easy to use. You still have to do this kind of get set thing inside there. It's a lot of repetition of code. And so there's some ways to make that go away and sort of automatically happen. They're just really hard to do that. And so we haven't done that yet. So I did all the easy stuff, and now the last 10% of the job takes 90% of the time. That'll be that. And make scripting within code easy to use. What I mean by that is not the scripts that we were talking about configuring in the UI, but, well, sort of. It is, but ways that you can easily add stuff to your XNAT to do things in just the way that you want to do them, or the way that you need to have them done for your particular deployment, without having to write Java classes and code that you got to go build. Ways to really customize the workflows, and by that I don't mean the workflows that we store in the database. We've got to change that name, but really the process, the business process, or the executive process that you go through for something. So we're looking at a number of different ways to do this, like integrating a workflow engine like Activity, or there's a bunch of different ways to do it. There's another Workflows Forever, and I don't even know about that thing. But we're going to try to integrate some of that functionality and to make it really easy for you to be able to configure what processes your data goes through from the time it comes into the system to the time it goes, ends up in a done or publishable state. So we'll be working on that. So we got a lot of stuff in 1.7. There's a lot of functionality in there that I think people are going to be able to take really good advantage of. The next thing that we're interested in, we're really working on making this an easily customizable and extensible framework and platform. And so we'd like to know what sorts of things you guys could use. What would be the tools that are not there in XNAT now that you really need? We already know some of them. We'd like to make searches more easily configurable and kind of more natural language. And I think also that the things that we've added in 1.7, once they sort of become integrated into the way that people work with XNAT, is going to also deal with a lot of the issues that we have in terms of things that make it difficult for you to be able to add in whatever it is that you want. But any ideas that people have, so like Hakeem is like, I can't find the XSDs. I need to be able to find all the XSDs in the system so I can go out, pull each one down and scrape it and get all the data types out so that I can build these automatically generated classes that let you just interact with the data type. I'm like, yeah, that's right. You can't do that. You can't do that. So, but that's the sort of thing that we're looking for. So any ideas that you might have for ways that functionality that we could add into the development framework, or functions that we could add into XNAT itself that'll help you discover things in XNAT or understand the way that this particular installation works, would love to hear those. So, and I think that's it. That's all I got, and it's 11:58. So.